Hello, everyone, and welcome to another Mendix Community meetup, and this time in collaboration with Capgemini. My name is Vries, and I'll be your low-code host today. And joining me is Wouter Penris from Capgemini. And you may know him from his Mendix World talk, where he talked about REST service native Mendix apps. Now, in that session, he gave an overview and talked about what that app did, the challenges, and in this session, we're going to take a deep dive, a hands-on deep dive into some of those challenges that you see, that you encounter when you're building these types of apps. So during the session, Wouter will be going through a couple of these challenges and solving them for you. If you have any questions, make sure you put them in the chat for us. And I'm just gonna interrupt Wouter when we have a question, and I'm gonna ask him, hey Wouter, what about this? So feel free to ask your questions during the session as you're watching us. You don't need to save them up for the end. And yeah, please enjoy it. Wouter, welcome. Tell us what you're going to be showing.
Thank you very much. Thank you very much. Let me just share my screen and we'll start right off. I hope everyone is getting nice and comfy. That's one of the benefits of having these meetups while you're actually in the comfort zone in your home instead of having to travel, etc. Let me just share my screen. Here we go. So indeed, this is a follow-up on the Mendix talk, the Mendix World talk I did. And one of the thoughts that we had was to actually show you how these problems arise as you're coding. So what I'm going to be doing in the coming, hour or so, is to show you hands-on what happens and how you get across these problems and how you can actually solve them. So, and again, interactivity is a must. So if you have any questions, ask them, please. And we'll make sure that at the end of the session, there is some time also to discuss, if possible. So let's dive right in. Thank you very much, by the way, Jan, for hosting this session. So the background of this app was a fintech app, and Mendix functioned as a front end, and that basically means that all of our data was gathered from a data layer in that sense. And so I presented 5 challenges and 5 solutions. I'm not sure if I can get to the 5th. It's quite a lot to process, but I'll try to at least show you how we dealt with each. And the first one was how to get data. Just showing you a bit of the architecture that was present. So again, it's a fintech, lots of security requirements that we had to take into consideration. And one of these resulted in the fact that we had to perform our REST calls through the Mendix server. And that means that we're, and I'm not sure if you can see my mouse hovering. Can you see my mouse, Jan? I don't hear Jan.
Yes, we can. Can you also click on the hide for the screen share? Yes,
of course I can. Yeah. So one of the things is that we would always start. So one of the aims of this project was to have a single logical base for both web and native. And in order to do that, and if you want to get data, then you basically have to run your logic from a nanoflow. And that's this yellow line that you see. So that's the nanoflow. And then it basically triggers that microflow, and each time you will be seeing the same pattern. So basically the blue line is a call to the Mendix server, which then does some kind of activity, meaning a REST activity, etc. So let's build the first bit. And what I'll be doing is using JSON placeholder to get a list of users. It's a very handy website if you don't know it, and if you want to tinker a bit with REST service calls, it's actually very handy. So I'm going to open that, and let me just see where that leads. So that's this, and I'm going to end the slideshow, and we're going to go over to Mendix. So basically, if I type in this users endpoint, I will get a list of users. So what I'll do is I'll just copy everything that's here, and I'll do as if this is one of those REST services that actually, interesting, that actually gives me some of my data, a list in this case. So this is my app. It's a basic app that has a native profile. And as you can see, I have home native and a home web screen, and I'll be working from that. First of all, if you want to build a REST service, then usually you have some kind of JSON snippet. So that's what we're going to start with. Let me just look that up. It's right here. I will just call it JSON structure. And I'm going to put this right in there, format it, refresh it. That's the first little bit. And then the second step would be to use this JSON format in a kind of import mapping. So let's generate some import mapping. Let me just find it. It's always a bit difficult to find. There it is. So that would be IMM. So something like user info list, because we're getting a list of users in this case. We'll be using that JSON structure I just created, selecting that and expanding it. And I'll just be using a couple of attributes. In this case, I'd like to have the ID, the name, username, email, phone, and website, and I don't want to have the array in this case. So I just like to have the objects and not the array that contains all of the objects. That's that. Now what I've done in my domain model is already pre-populate an entity that actually contains all of these attributes. So with a bit of luck, I'll be able to find that. It's actually this one. And then I can just map the attributes by name. And there's one left that I'll manually select, and that's user ID. That's it. So that's our import mapping. Then we'll go to the next little bit, and that's actually to construct one of these microflow calls that does the actual REST service. So that would be RS for REST service, user info list, and then get. I always add the protocol at the end. And in that microflow, which is about to open, I can just add a single activity, and that would be a REST activity. Oh, let me find it right there. Let me just close my email. That might be handier. And what we'll do is we'll copy that location of JSON placeholder. It's the URL, and we'll put this right here. That's it. We'll be using the GET protocol, and we'll be using the import mapping that I just created. So that's right here. And we'll be using a variable. In this case, I would like to have my user info list right there. And that's it. That's a basic REST service. We'll just set this as a return value. Now, the one thing that we've missed in order to make this accessible to both native and web is to actually put this into a nanoflow. So we'll add a nanoflow. We'll call it a DS, and it will be user info list retrieve. And within that, we'll just be calling that REST service. Now, obviously, there are a couple of things I forgot. Access rules. It's the thing I always forget. So let me just enter a proper variable name, user info list. And we'll be going to the security and setting it now to all, but you should be very careful, of course, on what you want and where. Basically, whenever you trigger a microflow from a nanoflow, you will have to set, you will have to give the proper roles for that user as well. So in this case, for all users, but be careful what you want, right? So that's it. Now we can actually get our list. Let's go to Home Web, and we'll add a list view. There it is. And we'll be able to just use our DS on the list view. And let's see if it actually does something like this. Nope, that's just a button. So I have to select it manually. Nanoflow, and then it is right here. User info list retrieve. I was hoping it would actually pre-populate it, so let me just see if I can trick it to do that within the home native screen. So we'll be adding another list view. I'm doing this on purpose, and I'll discuss in a bit. And let's see if we can drag and drop this in there. We can't. Did I actually put a return variable in there? That might be it.
Hey, Wouter, can you
Yes.
maybe zoom that in a little bit?
Yeah, of course, no problem. And I think especially from for the nanoflow, right? Or everywhere?
Yeah, especially nanoflow. I think people watching this, the quality might be a little bit lower than what we're used to.
Yeah. And there it is. Now it actually accepts it. So that's good. I asked it to pre-populate it for me, and we can do the same actually on web. Let's try to see if it pre-populates. Yes. Okay, that should hypothetically be it. So let's see if we can run it. We have no errors. I'll just run it right here, and I'll open my my screen to share my mobile view. So this is the Make It Native app running on my iPhone, and as soon as compile time is over, it should be able to show the application there. And I'll be showing it both on web and on native at the same time, because we want a single code base for our application.
Hey, Wouter, I have a question coming in actually.
Yeah.
Why do you need to call the REST service inside a nanoflow?
Yeah, that's a good question. So basically, I'll actually show you. So hypothetically, if you want to use that single logic base for both web and native, this is a requirement, because you cannot call on a microflow directly from within a native context. So right here, I have a native page. And if I were to drag in my microflow here, you see it won't accept this. And even if I look at the data source types that I have available in the native environment, you see that it's either a nanoflow or it's the local storage on the device. So that is why we need to enclose the microflow within a nanoflow jacket as of sorts. I hope that explains it.
Absolutely.
Cool.
Another question coming in, and I can answer this. Will this be recorded and we'll be able to watch it back? Yes, everything's being recorded. We will post a video. It will be available right away after we're done with the live session. So you should be able to share that with anyone right after the live session is done.
Yeah, and I think it's working. So right now this is home native, and here we're seeing our list. And this is home web, and we're actually seeing our list here as well. And in that sense, we've gotten our data. So this is the basic paradigm that we used to have that single logical model for both web and native. And of course, it's a bit, it's dressed down in security requirements. We had other things going on as well, but this is the basic premise. Let's go to the second bit then. I'll just slide back to the presentation. We were right here. So, and the second challenge for me was actually to find out or to come up with a solution for slow REST services. And again, as I mentioned in the Mendix World talk, one of the old adages was actually, or suggestions by Mendix, was to associate your non-persistable objects to either session or user. And likewise, you could do an association retrieve and get that information again. So since I've just actually created some logic, I'll just show you what that looks like. So we'll switch back like that. And we'll go to the domain model. And I'll try to zoom in a bit. So here you see the Mendix World logic, but I created a bit of extra modeling just for tonight. So we're currently using this user non-persistable object. And as you can see, it's not associated to any persistable objects. But as soon as I actually add an association, so we'll just add an association to system.user. There it is. We'll double click. And as you can see, we're immediately getting compile time errors. and it must be a bit difficult for you to read this, so I'll just read it out for you. And it says, return type well, anyway, that's the association is associated, or the object is associated to a persistable entity over path, blah, 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 which is not allowed in a microflow called from a nanoflow on pages that are accessible through a native profile. So basically what that means is any non-persistable object that you're showing on a native page cannot be associated to a persistable object. And so in Mendix World, I then showed you a slide that actually said, well, imagine having worked on a project, at least our fintech app, for over a year and a half with various teams, and then realizing that you have dozens of these associations, because we started native development a bit later. And so that meant that we had to refactor. And we're actually still working on that. We discovered it roughly in March. So it's now September, and we're still actually working on getting the refactoring done. We're doing it bit by bit, but this went to the very core of our application. So and that is also why I decided to have a talk on this topic, because this is a large problem. If you're starting work on your single logical model for both web and app, you're starting in web, you're thinking you're doing everything properly, and then you're suddenly finding out that you can't do this association. And it gets worse, because if I add this association to an indirect, so an associated object, it doesn't matter. It doesn't work either. So I'll again find system user. That's the one. Just press enter. And it's, as you can see, the same compile time errors pop up. So basically, the question then is how you solve that. And that is actually the third challenge that we have. Okay, we can't use any association to reuse objects. So how do we tackle that? So that is the third challenge. So let me just show that on a slide.
In the meantime, Wouter, you're getting some kudos, clear explanations, and you are answering all the questions I currently have. So,
okay, excellent.
Nice work.
So yeah, good. So yeah, how do you combat that challenge? Non-persistable entities associated to persistable entities. And what I showed on Mendix World is that there are two options. And the first part is to actually use a sort of root entity. So root, non-persistable entity, you could call it whatever. You could call it a nav tracker or a root, or basically that's an object that you embed in your main page. And as you travel down any of the associations, you will always have access to that root. And likewise, you can traverse your entire domain tree or hierarchy. And what I showed as well, and that's something that I'll try to pay a bit more attention to in the coming minutes, is that you might have a problem associating with entities that are a child of the system module, such as, for instance, system.image. What if you need an association to those kinds of objects? In that case, you can use an ID duplicate within the non-persistable object. But I'll show that in a bit. So as you can see, I made a slightly different implementation, and let me just holler out if it's clear enough and visible enough. So we have, yeah, okay, cool. So in this case, we have user non-persistable. And for the next exercise, I'd like to have three lists, which I'm going to call on again and again, without having to do REST service calls each time. And so that's what we're going to do right here. And I have some objects that I can already use. So first of all, I need to include some bits so I can actually go to the next page. So I'll be doing that. I'm going to include some logic right here, and I'm going to include a snippet. And in this case, that snippet is a very simple link, a button actually, that I'll put at the top right here. And it opens that third challenge. It uses this nanoflow, so I'll show you that nanoflow as well. And I'll just zoom in for you. It's basically going to show me my blank canvas to work on. And as you can see, I need some sort of data. And I pre-prepared a bit of logic for that. So let's see if I can find that. It should be somewhere. I'm just going to get it from the working version I have and cheat a bit. Yeah, here it is. So it is, no, that's not the right one. It should be something with root, but I'll just do it like this. Microflow. I'm going to add a microflow. That is going to do all of my REST calls. And in this case, since I'm showing 3 lists, I'll be doing 3 separate calls. And that is something with root. Get data, that's it. And it will deliver back my root object. So I can use that. Subsequently, I can actually use that root for my page. So before or maybe I will compile and then show you the actual page, or will I do it like this? Let me show you the page first, but I still have an error, I see. I don't have that page, so let's just add that page. This is the one. Yeah, that should be proper. At least one row. I always forget that. Thumbs up if you always forget that that setting on allowed roles. So we'll just compile. And so basically, this will allow me to get data. And in the console, I'll be able to see that actual REST service calls are made because I put a trace on the log levels for any type of REST consumption. As you can see, REST consume is set to trace in log levels, and REST publish is set to trace as well. And likewise, yeah.
I've got a question here from
yeah.
John. Can you show the microflow?
I can. The microflow is actually a good one. It's very simple. It creates a route, and it passes that route to each of the REST services. And these are basically the same types of REST services I just showed you how to build, only they talk to different endpoints, and they have a slightly different entity. But in essence, they do the same. They supply me with lists, and they attach these lists to the root. So that looks a bit like this. So where you have a user list, it's tied to root non-persistable, and the same goes for this and that. I'll just show you one because in this case, I can imagine that you might imagine that it's a bit different. So in the import mapping, here we are using our root object, and we're passing it as a parameter, attaching our list of non-persistables. And this is what we're doing with each of the non-persistable objects we have. And as you can see, I think it already ran. Let me just check. So here I can go to challenge 3. Let me just push the button. Well, it's not doing anything, I think. Let me clear the logs and we'll try again. To challenge 3. Nope. Let's check to see what has gone on. So this is the logic that was used here. We'll just check to see whether in that snippet we're using the proper logic. And since we're running Mendix 18.6, I don't have nanoflow debugging yet, which I know is present in Mendix 9. So I'll just cheat a bit, and I'll put a breakpoint on the microflow that we've put inside here to see if everything is being triggered properly. I think I just have to recompile because I changed that microflow or that nanoflow. And then theoretically that button should work. To challenge 3, we'll clear the logs. So right down here, you can actually see all of the logging that should go on with each REST service call. To challenge 3, we're getting a breakpoint. I'm letting that go, and have we done any REST service calls? We don't have any. We do have logs. Here they are. Excellent. So basically this means that now we have a page with a root object in view. Let me show you that root overview. That's right here. I can actually show you that this is my cheat sheet. So I'll just do it right here. Root blank canvas. So currently it doesn't do a lot. But now we're actually going to traverse down our domain model. So we currently have this object in view. Let's say I want to go to my list of users, or I want to show my list of albums. So I can do that quite easily. I've prepared a couple of pages, and what these pages do is very simple. I'll just show you. This is a page in which we also use that root, but we're using a nanoflow data source. And that nanoflow data source is very simple. It does an association retrieve on the root. That gets you that list of non-persistables, and it returns it. That's what it does. So let's drag these into our canvas. Let's see, it was right here. I'll just flip that in. That's number one. That's number two. These should be fine for now. We'll just compile again. And hypothetically, I should be seeing two buttons right here that would open these pages. There we go. Let's click on challenge 3. I'll get rid of that breakpoint because it's all working. It's always fun when stuff works. Okay, so here we have our two buttons. So it doesn't look like much, but these are actually two buttons stacked on top of each other. I can click on the one, and we're doing an association retrieve. And as you can see, if I move backwards and forwards, no new logs are present here in the screen. So if I clear this, then I'm basically making use of all the logic that has been stored in memory. So likewise, this is a solution in which you can reuse non-persistable objects by tying them together with a root. Let me just stress a couple of things. So you might wonder, we've got user ID here and user ID here and user ID here. Why did you choose this domain? It looks a bit illogical. Well, this is just to show what you can do with non-persistables and the pattern of using a root object that will allow you not to do REST services each and every time, because REST services are a bit slower. Yes, they can be quite fast, but if you really want that snappy view, this is a way or a pattern that you can apply to reuse some data that you already have in your native or web client. So I'm just going to skip this for web, because this will all work on web as well, and I could build it there as well. Trust me, the most challenging bit is to get it to work on native. But if we have time, I'd love to show you the same on web. But all of these actions and nanoflows will also work for web.
Yeah.
Yeah.
Let us know in the chat what you guys think of this, and if you have any questions on this. Do you want to see something specific, or do you want to go to the next challenge, maybe come back to this later? Or maybe you have a completely different question that's not related to any of these challenges, but still in the realm of native and REST. Let us know in the chat. I believe we have another challenge, don't we?
Yes, we do. But I could also extend this, and that's what I hinted at initially. Because what if you want to, for instance, get an image on your screen? And in this case, we're having an album overview, right? And what if I want to show an album cover of sorts? Well, we can do that as well. And we do that by actually creating a persistable child of system image. And I already pre-populated that. So we're just going to see within our app here, right, on the image overview that I generated earlier, I have a single image right here that I uploaded. So what if I want to use this image as a standard, right? So I might have very many images, but this is the one that I actually want to show as a sort of dummy image. I can't associate between these two because then I'll get that same compile time error. So what I did is I added an image ID, which is a copy of this auto number. And in this case, I just put the image ID to 1. So it's going to always show that same image, namely the one that we have right here in our image overview that has the ID of 1. But hypothetically, you could make that dynamic in any way that you'd like. Let's see if we can get that in. So here I have a snippet album image. We'll just open the image overview again, and I'll zoom in a bit. Let's say that I would want to have that album image right here. I'm just going to drop in that snippet. And what does that snippet do? It's actually very simple. It has the image widget to show the image, and it's contained by a nanoflow. Let's check that nanoflow. What does it do? So we have that non-persistable object as a parameter here. And what we can now do is we can check the local storage, because if we're working from a nanoflow within a native context, the local storage will be checked. And in this case, I'm just taking the first image that is present within our storage because I only have one. But in this case, you could add the XPath constraint that would tell you to actually get the image with an image ID of album non-persistable. I'll just put that here. Let's see, incompatible expression types, integer long, and that should be... can I do that right here? Just checking. I think that should be a string. I'll just use the first for now. We could check that later. I'd have to create a variable, but it's not the most interesting bit. The interesting bit is actually the synchronization rules that I have to set later on. So for now, I'll just take the first image that comes if there is an image on my local device. That is the question. So we're retrieving that album image and we're feeding that album image back. Let's see what this does.
In the meantime, Wouter, I have a question coming in.
Yeah.
Well, two things actually. One is more of a statement. This practically is session caching, isn't it? And the other one is, have you considered other ways of caching data, such as in local storage and refreshing when necessary? Is that possible with non-persistable entities?
Yes, we have considered other means of storing data. In our case, for this application, we sort of identified two types of data. One is the very static kind, and actually the most static kind of data that we have is actually the information about the user itself. So that is like a name, address, and stuff like that. And I'll be addressing that in the next part of the solution part 2. And we have these sort of flexible or dynamic kind of data, such as, for instance, an example for a financial application would be transactions. A transaction data is something that we would like to get in using REST services. So if you just have these two types of information, this is, at least in our case, this was the most, at least the pattern that we decided would be most applicable.
Got it.
But I'd be very interested in hearing your thoughts on how you would solve this, by the way. So please put it in chat and I'll be able to read it later on. Or maybe Jan is willing to actually share some of this. So basically what we've just done is add that image. So I'm going to open my album overview. And right now we see that we have images here. So what I'm going to do is I'm just going to delete this image to see what happens, because I've got to show you this bit of logic right here in your navigation. And this is within the native profile, you have synchronization. And currently you can see that I am synchronizing all objects. So let's see, I'm going to clear all of the data. Can I do this in some other way to quickly clear the cache? Let's just check this because it might not trigger. because what I need to do is I need to add an activity to the opening of the root page. So that's right here. I actually need to put in a synchronization activity. And this will actually take care of bringing over any object that I want to have present in my local storage, depending on the rules I set within the sync setup that I just showed. So let's add that synchronization activity. There it is. We could do selected objects, but for now we'll just do all. So that means that for any type of synchronizing setting that we have in our native navigation panel, that will be triggered. So we'll just run again. And as you said, I said clear. So it should hypothetically clear everything. So let's see.
By the way, people in chat are helping you with your expression. They said, just put the ID after album NP.
Ah, yeah, that was the one. Yeah, that's the stress of presenting and actually thinking of logic. So thank you very much.
Thanks, Martijn.
Yeah. So compiling again. And let's see what happens. It should refresh in a bit. So I have a question to the Mendix community. I was actually wondering why at some point compile time is actually very slow and at other times it's really snappy and quick. And in this case, it was a bit slower. So if any of you have any answers to that, I'd love to hear it. There it goes. So let's go to challenge 3. So now it should synchronize. It's actually doing that. And let's check. And now I don't have my image, so it's not showing it. So this is where you set up your synchronization configuration. It's really important to remember. So if you want your object synchronized, you could add an XPath constraint, but you could also do that within your domain model itself. That's up to you. This is where you do it. So hopefully if I compile again, it should be a bit quicker, and then we should see that image again. So that's it, how you associate by using an attribute copy. Let's just double check to see if everything's present on screen again. Hypothetically, it should be. Now it's a bit slower. So meanwhile, I'll just do a click and some scrolling to see if I've done everything. Yes, I have. So, and there it is. And there it goes to challenge 3. Album overview. And there we have our images again. So that's it. On to the second part of the solution. And let me just open the right slide for you to see. And that's this one. I'll just scroll to the proper one. I'd actually opened it properly. Here it is, challenge number 4. So what do you do with the static data that you have in your project? And I already said in our project, we sort of consider there being 2 types of data. One is the very static one, such as your own name, so the user information. And we were considering, can't we make use of that local storage, that offline first paradigm that native is actually so good at? Especially for stuff like your name, your email address, etc. The information that you use on nearly every screen, should you want to do REST service calls for that. So that's actually the second part. And in my Mendix World talk, I already sort of hinted at how you can do that. So for instance, you can have a user info object and associate that to user. That'll work actually, because no cross combinations between non-persistable entities and persistable entities. So in this case, that should work. The question is how you present these side by side. That was also quite the challenge. So the aim of the next exercise is to actually get a persistable type of information within our application, just to sync that and store that within the local database, but we do not want to have that information within the Mendix cloud. We'd rather not have it there at all. And in this case, we were bound by a security principle that had been set out that the Mendix front-end layer should not contain any sensitive data, or actually not any data if possible, but especially information such as a user's own name, email, stuff that is GDPR sensitive. That is information that we do not want to have within the Mendix cloud. Just to show you that slide again on how our setup was. This slide, I mean. So basically, we need to make use of the storage within the Mendix server to actually get our persistable objects onto our client, as we couldn't do any direct calls to the data server because of security requirements again. So that is why in the coming exercise, I'll be using the Mendix server temporarily to store a persistable object. I'll be synchronizing it to the native client, and subsequently I'll be removing it from the Mendix server. And it should, hypothetically, if you have the proper synchronization settings, it should stay within the native client at least until the session ends. That means that the user is either, for instance, logged off. So it doesn't have to be that the user closes the application, but he really has to log out his session. That means that for our users, all users would be logged in if they were to access their user information. They would be a known user, not an anonymous user. And when they would actually log out, all of that data would be purged from the local storage. That's something that Mendix actually takes care of automatically. So let's go and take a look at the fourth challenge. So again, I've pre-populated some bits and bobs to put in. And I'll just put this in the root canvas right here. I'm going to be taking a look at this. So let's open challenge 4. We'll drag that in. I'll show you what that does right now. It's simply the same as what we just built. So only the page is different. So it does that REST service call that gets us our data, and then it shows us, in this case, our blank canvas number 4. And what you can see here is that, first of all, our non-persistable object is our page parameter. And this is important to consider. If I were to put my persistable object, in this case, user, let me just show you that object in the domain model. I have a user right here. That is a child of system.user. So instead of associating it to user, I've made it a child in this case. And I actually created a similar service that gets me my list of users. Let me just show you that temporarily, what that looks like. So here is a user overview. So I created a little button with which I can basically delete everything. So these are my persistable users. Now they're gone. And I can use a similar REST service. And let me just show you that that actually does happen. So you can see that here in the logs. I'm going to sync users, and you just saw something pop up here. And now I actually have my persistable users. It's the same, or at least similar logic, but it's a different type of mapping. In this case, we're mapping against a persistable object. And we're doing a commit. So here you can see that I tapped the same endpoint on JSON placeholder, and that resulted in our list of persistable users. Now the question is, how do I get that user information on my screen? So within my blank canvas, I already put in a little widget, and in this case, it's got a very rudimentary data source microflow. So this is going to poll on the local database. Let me show you what it does. It won't work if I compile it like this, because what I'm currently doing is from within, or at least from a native context, it will poll on the local database. That's what it's doing. So it's just basically trying to grab the first user that it gets. So it's a persistable entity in this case. In a perfect world, obviously there would be some kind of guard here that would get the right user. So what do we need to do? So hypothetically, we need to get a user from the local database. If it doesn't exist, we are going to get the object via a type of REST service and sync it. And subsequently, a local retrieve should work. Well, we've already done a REST service in this case, so let's see what we can do. Let's add a condition in this case to see if we've actually found our user. And if I have a decision right after a retrieve, I just do this. So in this case, I want to know if the user not is empty. Control Enter. So if we have found it, then we can just pass it back. So this is the true condition. Happy flow always to the right. Let's now devise the unhappy flow. We'll be going down and we'll be making use of a microflow call. And in this case, I've pre-prepared one. So this microflow call, actually it's a user. And I've pre-prepared it right here. I'll show you it in a bit. I think it should be here. It's not opening. I think this is the one. So this will get me an object, but let's take a look at this first. I'm going to put an end event right here. And hypothetically, I'm going to return, that's not the right object, that's the problem. Let me just look at my cheat sheet right here. That's why we have that cheat sheet. This is the one, oh, oops. That we did, working version. This is the one. And there's actually an error there. Is that the one? User first, and I'm quite sure that there's another one. Yeah, there it is with RS. This is the one that I was looking for. So we'll go back to our user first and now select the proper sub microflow. Yeah, I'm in the right one. There it is. Let's take a look at that one. So what does it do? So here, first of all, we're going to pull on a REST service. And that REST service is quite simple. It does a call on the same endpoint, but in this case, I'm just asking for a single object. So that's why there is a parameter, a query parameter at the end. So it'll return a single object. And we'll use some mapping that maps this to the persistable entity that I just showed you. And once we get that back, we're passing it back to the main microflow. By the way, it's interesting for those of you who haven't worked with native yet. I know there are quite some, but if I were to use this microflow directly in our nanoflow, let's just try that out. This is the nanoflow again. I'll just put this in here just to show that what happens actually. So we will get compile time errors in this case. So let's just click on this so that we have our return variable. Persistable entities are not allowed to be return values when calling a microflow from a nanoflow on pages that are accessible through native profile. Basically, it's saying any type of logic that is called on from a native context. In that context, you cannot feed back persistable entities. So you have to make use of synchronize activity. So that's what we're going to do. So, and I'd already started that right here. we have our user info that gives us back our single user. I'm just going to commit this to the Mendix Cloud database because we're in a microflow, and that basically means that if I do a commit, that is right here, a commit without events in this case because I don't have a password set, so otherwise it'll trigger validation logic. If I do this, then it'll be stored in the Mendix Cloud. This is the essential action here, that you synchronize that user to the device. So in this case, I've selected my user, and basically that means we can go back to our nanoflow. I hope this sort of makes sense. If you have any questions, do holler out. You might think that we are actually done at this time, but basically we still don't have a user. So we could do two things. We could make this a nanoflow recursive, and I could just put in user first again, because if it were to put, right, if it were to actually trigger the local database again, that's what's happening now inside here, then this would be found, but recursion, it's not very nice, right? Always be very careful with recursion. So what we'll just do, we'll retrieve that user from the database again. And hypothetically, now that we've synchronized, this should actually be on my device in the local storage. As we're working from a native context, we're using a nanoflow, we're doing a database retrieve, that means local storage. So again, I'm just taking the first one. It doesn't really matter whether you feedback or synchronize a list of objects, persistable objects, any type of objects, it works like this. So now we have user one, and we're going to set that as a return variable. Let's check what it does. I don't have any compile time errors anymore. I put this snippet to page 4 on my page, so let's take a look. So maybe Jan, maybe you have another question for me?
Well, it's an actual response to your question about why some deployments might be slower than others. Someone said, my guess it's because it's based on React, where it serves as a live server. So depending on what type of changes you made, it takes longer to recompile. Okay.
Then I'd have another question saying, is there any way to predict these kinds of changes in compile time? Because that would be really interesting. It's just something that that I was wondering about whenever compiling. So thank you very much for your answer in that sense, and for the community to think along. Okay, so it's just compiling.
Do you have any best practices for development like this? Because you mentioned, recursive is of course generally not a good idea.
You can do it, but just be careful if you do it. Some of the most nicely designed bits of logic that I've ever come across use recursion. So if you're very careful with what you're doing, recursion is actually so sleek and elegant that it basically allows you to forego a lot of duplicate logic. So, but yeah. I think you had a different question here.
So no, it was just a general question of best practices when doing development like this. Is that something you establish on your own? Is it something that you establish with your team? Where do you look for those best practices? Do you look at what other people in the community are doing, or?
Yeah, it's a good question. I think it totally depends on on the context again. So for who are you developing, and how accessible should your logic base be? Recursion is something that makes your logic difficult to read, because you need to open that same logic again, or actually be capable of keeping that recursive bit of logic present in your mind. And I found that many developers actually find that challenging. So in that sense, I try to forgo recursion if possible, unless we're making use of some very complicated bits of logic, which I definitely not want to duplicate. But then I always put an exclamation mark or a kind of annotation in my logic saying, watch out, recursion going on, so that if you need to debug, you can actually follow what's going on, and you're sort of flagged already, in the sense that well, you're sort of aware that some type of recursion is going on. Otherwise, you might have an infinite loop, and you never know actually where that comes from. You might not even be aware that it's ongoing, and your system might be getting slower and slower and slower, and you're wondering, how do I solve this? Well, usually it's shutting down the Mendix server and starting all over, but or adding a breakpoint if you're lucky. Yeah.
Yeah, that's a solution to that problem, like when it's happening, but of course not a root solution.
Yeah.
How many people would be working on a project like this in your case?
The entire project, or just the Mendix part of it?
So in this case, the Mendix part of it. So how many people would potentially see or get to touch these type of microflows and project files?
Yeah, so depending on what type of developer, we've got a couple of citizen developers. And we have a sort of steady base of, I think, about 8 to 9 Mendix developers, and so it varies over time actually. For instance, we've got someone translating, so she's a citizen developer. We've got someone translating within Mendix. And also for her, it should be important that she can actually read what's going on when she needs to translate validation messages or something. But that's just an aside. Yeah, hopefully that sort of answers. But oh yeah, looking at the entire project, how many people are working on it? So the entire stack, I think it's over 150 people actually. I don't know all of them.
Wow.
Yeah, it's a big one.
It is, yeah, for sure.
Yeah.
There's a comment here from Renee about recursion. Instead of recursion in the main microflow, it would make sense to do that the user retrieve in a subflow, which has the same benefit of reuse and maintenance without the challenge of the remaining main flow execution.
I couldn't agree more. Yeah.
Perfect.
Yeah.
Well,
basically means that you're putting a sub nanoflow right here with this retrieve action that you can reuse right here. Excellent. Yeah. Okay, so let me just show you. We actually have data within our app, but the question now is that data also present within the Mendix database, right? So, and the answer to that is unfortunately yes, it is, and we don't want that. So how do we solve that? We chose to do it like this with a scrubber. Let's just see if I can find that bit. Because looking at the time as well, I'd rather actually show you that scheduled event I built for this. So here's the bit of logic. This is the scheduled event that triggers the logic. I'll show you that in a bit. And this is the actual logic. So like I showed on Mendix World, in this case, it looks at 10 seconds ago. Any data that's older than 10 seconds ago, it's retrieving that. So you can see created date equals or smaller than 10 seconds ago. And then we're just counting it here because we're going to do a log message on this. And basically, we're going to delete this in this list. So, and when I delete it, depending on my synchronization settings, I will still be seeing my user information when I traverse backwards and forwards to this page. So we'll be seeing that. So I'm going to turn on the scheduled event to scrub this. Let's see, it was turned off. Let's turn it on. And then I'll need to recompile. And hypothetically, we should get logs here saying that user info is actually scrubbed. Oh. Ah, yeah, naturally. We first need to have a server running before we can actually start. And there it's going. Yeah. Okay, so let's try and open the application again. You see the scrubber is actually already in progress. So if I open the application on web, I will not find any users here. So once I open challenge 4 right now, I still have my user info, even though I've been scrubbing this. That's because the object was synchronized to my device, and I put in these settings for this object. Let me just show you that in the native synchronization configuration. So here I basically said, we're not going to synchronize, we're going to preserve data. I didn't put in an XPath constraint because normally you would actually do that on the user info itself. So on the object itself, you would make sure that only the user that owns the session can actually access that data. So basically, this is the way to show both non-persistable and persistable data within the same page. So even if I go backwards and forwards, you can see that the scrubber is still going on. I'm opening that. Yes, I'm getting my REST service calls, but these are for the 3 calls for the actual list. So albums, post, and user non-persistables, but not for the persistable objects. So I could go backwards and forwards to my non-persistable objects, and it would work. This is so the question might be, what is the use case now? Yes, you have your user and you have your non-persistable objects. Well, now we actually need to start combining those, right? Because usually you would only like to see your own data. And usually that means that the data has some kind of restriction on it. And as you saw earlier in our domain model, there is actually a user ID on these with which we can do some sort of filtering. So that's what I could go and do right now. So hypothetically, if I just open my canvas, if I were to go to my album overview, I could put in the logic to retrieve the user and filter that data on user ID. I'll just show you what that looks like within the working implementation because we're limited in time a bit. I have a button in the top right here that I can actually click. We'll go to number 4. And this is number 4. And if I go to my albums or my posts, you will see that this is only information for user 1, 1, 1. And it looks like this. To post overview, and that's a filtered page. It uses a nanoflow again, but it filters the information. So right here, I'm calling that same data source microflow. We have that local user present. I haven't built in any checks yet, so normally you have to do that. Obviously, what if you don't have that information and you're going to do filtering? That doesn't really work, so you'd have to do that check. Then we're going to do an association retrieve on our post list. That is a list of non-persistables, and subsequently we need to filter that list, and in this case we're filtering it on the user ID, and that returns us this filtered view in which we can see that the user ID, which is the first one, is indeed working. The filter is working. So you can imagine that you might actually want to do this filtering while doing the REST service itself. That's also an option. So that you would never even have these non-persistable objects belonging to the user in the first place. So that would actually be best, would be the best way to go forward, obviously. Okay, I think it's time to go to the final challenge. And that challenge is right here. So microflow produced non-persistable entities within nanoflows. And this is quite a challenge, and it basically works like this. So whenever you're using microflow logic to create a non-persistable within a native context, so again, that means you have a microflow that generates an object, passes it back to a nanoflow. Now it's in the native context. If I feed that object back again into another microflow, I will get problems. Either I'll get compile time problems or I will get runtime problems. And I'm just going to show you what that looks like. So I pre-built a little bit of a page again. It's right here. I should be able to add that page. Or let's just, let me just find the right one. No, that's not the one I'm looking for. Act album delete. Let's check that one. Is this the working version or the... Ah, here it is. Actually, here's where I wanted to start. So again, it's a similar page. We're showing that root object. In this case, I left out the user, the persistable user with that information, but in a perfect world, you could still present that side by side. I'm showing an album list in this case. And now I would like to actually be able to delete one of the items right here. But before we do that, let's just check this one. Yeah, this is the button that I actually need to add. So this is the opening of the page for the canvas of challenge 5. And this is just a little bit of a bogus flow that I built. So this is a REST service that gives me a non-persistable list. And I'm just going to put that list back into a microflow. So again, we have a nanoflow that calls on 2 microflows. In the first microflow, I get a list, and then I just return that list right here. So here you can see that I'm putting back that list. Let's try to compile, and should give me a compile time error. Or I did something wrong, then it basically isn't hooked up properly. I think I might have forgot to put it on the actual page. So let's try again. So as soon as I put this on a native context, it should fail. And there we are. We have an error that basically says variable user non-persistable list cannot be passed to sub bogus as a parameter because it is returned from a microflow. Non-persistent objects cannot be passed as parameters to a microflow when they're returned from another microflow in nanoflows on pages that are accessible through native profile. And if you do so, you will get a compile time error, but that's actually the best case scenario. You might also run into runtime errors. So I hope that this is really clear. That so how this works is basically like this. Let me just show you again on the overview, just to make it a bit clearer. Otherwise, it might be difficult to understand this. So I'm doing my REST service call right here, and I'm giving back a list. So now this list is in the green context. And as soon as I give one or more of these objects back to the blue context, I will get a compile time error. If I trigger that within the same nanoflow context, I will get a runtime error. That means I won't see it during compiling when I press play. If I separate the bits of logic. So imagine, I'll just take out this bogus button. Imagine I wanted to delete one of these non-persistable albums, right? And then I would have to do a microflow call to the server saying, hey, delete the object with ID X or something like that. Let's just do that. I have a snippet that will do an album delete. It's basically a button. And what does the button do? Let me show you that. It's a nanoflow that will feed back this parameter into this album delete, and it doesn't do so yet. So let's go and hook that up. So basically I want to have my album parameter, and I'm going to feed it back right here. I just put a bogus error handler on this. Why? It's because JSON placeholder doesn't support any delete protocol on their endpoints, which is logical. I need to map my parameter, and it will allow me to do this. I will not get any type of compile time error. As you can see, all errors have been resolved. So let's just run and see what happens. So let's scroll to challenge 4, challenge 5. Here we are. We have our delete button. So this is a list of non-persistables. Let's go and delete one. So what it'll do is it'll trigger this flow that you can currently see. Let's do that. And there we go. This is our runtime error. An error has occurred that might have been caused by fast reload. Reload the app to fix it. Well, in reality, that's not the actual cause. It is the same problem that I just showed you while it was still a compile time error. But basically, you can't pass non-persistable objects to produced by microflows to another microflow. And that is what we're doing on this page. We have a list of non-persistable items, right? And for one of these, we're going to trigger logic, starting with the nanoflow and back into a microflow. And that doesn't work. So what we've done, we've solved this problem by changing the parameter within this delete flow and turning that into an album ID. So now this becomes a primitive, and we can return primitives because that is not an object. So that is now a primitive. I'll just press cancel here. We will go back to the previous screen. That was it. Oops. Album delete. That's the one. We just need to change this parameter now, as we need the integer. We have an album ID here. And hypothetically, if we compile this is a solution that we are currently using for single objects. So whenever you have a list, there is a problem because, yeah, how do you pass back these lists of items when you don't know their length? Hypothetically, we could have very many parameters, right? We could add 10 or maybe 20, and we could basically try and see how many of these parameters are actually filled. But we're losing the benefit of actually having a list in that sense. So we're separating that list into separate bits, and then actually rolling out our logic one by one over the list, and that's not what we want. We want to be able to use our list logic that we know by standard. So let's just go to the 5th screen, delete, and now it will actually work. So it's done a REST service call, and just to show you that, you can see that in the logs already, a delete call has been done. And actually, it's been throwing an error in this case because this protocol is not present. So it's giving a 404 not found. It doesn't recognize the protocol. So that's it. So we're still left with the challenge of returning lists. And just to give you the overview of the solutions that we've provided, let's write this. So yeah, we could copy the object. If you do that, you have to set access rights because any logic that is performed on an object within a nanoflow in a native context will require write access rules. And that's a problem if you're talking about certain variables. You're basically opening up a can of worms. Some attributes you might not want the user to change. And when you're setting write access rules, that's problematic. So that wasn't an option for us. So yes, we can use primitive parameters. The downside is that you're sort of losing object cohesion, right? So we're having these objects in the first place to sort of store together a set of attributes, and that's what we're missing right now. And there's no way to return lists like this. There is, but you never know the length of the list. So if you, for instance, were to select 50 items from a list of transactions that you might want to archive, hypothetically within a financial context, That list could be 50 items in length, but it could also be 5 in length. You never know that. This is not a way to model that properly. So this is not a proper solution for that. So we had 2 further ideas which we haven't been able to explore yet, or at least we haven't decided to explore. A JavaScript copy action could be an option in which you write actual code to copy the object. Well, the downside of that is that you're losing your low code benefit, right? So we're actually adding code, and what if there are updates, etc., to either the JavaScript library or to Mendix itself? Will that be future-proof? So that's also something that we decided was not a proper option in this case. You could make a persistable copy of the entity and use an upstream sync. That's also a possibility. But then you have 2 types of objects for actually the same representation. And that's also something we decided would not be good enough in this case, because we want that single logical model for both web and app. So we're still stuck here. We're going to keep researching this option. I actually look forward to receiving a couple more suggestions from you on this, because lists is still somewhat difficult. So these are the challenges and solutions which you can also go over in my Mendix World talk. Some references again, and I think that sort of ends the actual session.
Fantastic. Wouter, thank you so much for demoing this. There is a question from my side. In the future, how can you prevent some of these challenges that you've run into? Of course, you've provided certain solutions, but we know this now after you've ran into it and solved it. For other issues, is there a way that you can maybe prevent these from running into these? Is that an option, or is it just you prepare as much as you can and you go and you prepare for running into these challenges?
I think what you're asking is there a way to prevent this while developing? And the answer to that is that you have to know the patterns to use. And this has actually taken us quite some time. We had to sit down really with a Mendix expert services. We sat down with them and considered the various options. And eventually we made a choice that would be best suited for our project. And yes, that gives us a set pattern and paradigm to work with, but sometimes it's still difficult. So for instance, if we have new developers who are not aware of this paradigm yet, they'll be struggling with the same bits. And that is one of the reasons, again, why we decided it would be handy to actually have this showcase. So not just the Mendix World talk in which it's explained really fast, but also this session in which I just show bit by bit how you get to the actual errors, and that you can get a bit more of a feeling on what could go wrong. So that was our aim. So hopefully these 2 sessions will be your way to go if you run into these problems.
Absolutely. I have a question here from Shors.
Yeah.
I haven't tried it yet, Wouter, but would a JavaScript action with JSON.stringify and import mapping on a backend work?
Interesting. Could work, yes. So basically what you're trying to do then, the question is, I'd have to try it out, because if you want to create an object, so in this case, the non-persistable object we want to feed back, right? If you want to create that object and it's in such a way that it actually fits the Mendix context, I think you will need access rules. And again, then we're at the same problem. For some attributes, you would not like to have write access, because you're feeding back data into the Mendix server, which is eventually going back to a data layer. And for data integrity purposes, that is something, and maybe also for security, you might not want to do that. So I'd have to look into it, but it's a nice idea. Thanks.
All right. I think you guys need to get together and see if you can figure this one out.
Yeah, but basically, if you want to get in touch with me, go and do so. I'm available on LinkedIn. Send me a message there, or maybe through the Mendix Slack community. I'm available there as well. So feel free to send me a message in that sense if you'd like to talk a bit more.
Excellent. Yeah. So Shors is commenting, yes, in the import mapping, you would only import the attributes that allow write access.
Yeah. Yeah. So the question then is, what about the attributes that you might also need, but that you don't want people to change? The key one being a user ID. Because for our project, user ID is the holy grail. So we can't let people touch that. If you can actually change it, we have lots of mechanisms in place which will prevent tampering. But hypothetically, if you would look under the hood and you would have write access to this, you would hypothetically be able to breach that single layer. So it's a no-go in that sense. And that brings us back to the how are we going to solve it then? Because we would need that that user ID attribute. Yeah.
So talking about solving problems during this whole process of refactoring and figuring out how to solve this, what kind of resources did you use? Was it mostly internal and working on this together? Did you use any outside resources, documentation, videos?
Yeah, we did. So we used the Mendix documentation that was available at the time. And as you saw, actually, it's also because Mendix native technology is rather new, right? I think it's 1.5 years old. And the documentation at that time still gave us the solution to this problem that would actually block us, right? The association between non-persistable entities and persistable ones. And so in preparation to Mendix World, I spoke to Danny Roost, who wanted to check out whether I'd be somewhat critical on Mendix. But I'm not. I love Mendix, and hope that you can see that as well. I really think it's a fantastic platform. But he wanted to make sure that, well, what was going on here, etc. And one of the first things he did was actually change the documentation so that now if you actually look for the same problem, you will get the right information. So that's actually very good, I think. And I think that indeed together as a community, we can improve our experiences as we go forward like that. Any other types? Yes, we made use of an expert service. And that was just to consider options in this case, what we should do. And it also had to do with looking for a way out of the refactoring work that we had to do. And again, having multiple teams work on this Mendix project for 1.5 years and then realizing you've got to refactor. And this really goes into the grain, into the layouts of the pages. Basically, we had to touch all aspects of the application. And what we wanted to consult with the experts on was the Mendix experts and expert services was, is there a way to sort of forego that? And there wasn't. So had we been better informed, we could have forgone this. So, and that was our primary aim, to inform you guys so that you don't have to go through the same troubles. Yeah.
Good. Yeah. Well, it's great that you're sharing that here with everyone. What would make it easier next time, or what would have made it easier next when you started this in terms of content or knowledge or information? What would have made it easier? Is it better documentation? Is it more information sharing between community members? Is it or maybe there isn't. Maybe there isn't anything that could have made it easier, except
I think there are just basically some things you just have to learn. I know that Mendix is working hard on this, and I suspect that in future we will actually that it will be possible to return persistable entities from a microflow within a nanoflow on a native context. and that it will be possible to return non-persistable entities produced by a microflow to another microflow within a native context. I know that Mendix is working on this really diligently, so I trust them in that sense. So hopefully this will be a sort of temporary workaround. And now Mendix is really improving quickly. So all I can say is that I'm really happy with the way that things are improving and the speed at which they're improving. Yeah.
Do you have any plans of upgrading right now? Because it was to Mendix 9, for example.
Yeah,
it's
we do.
8.16, I believe.
Yeah, 18.6, I think.
18, yeah.
So we're planning to upgrade as soon as possible. In this case, we had some interdependencies with other layers that sort of limited us. I won't go into details, I can't. So, but yes, we are planning on doing that. Yeah.
Interesting. Maybe we'll see another blog or video on upgrading this native app.
Yeah, interesting. Yeah, that's actually going to be a challenge in itself, especially with the new Atlas UI. So, yeah.
Yep. Yeah, that's a whole new challenge there as well. Yeah.
Yeah.
All right. Well, that brings us to the end of this meetup. Wouter, thank you so much for sharing and building with us. I want to call on everyone here who's joining us today. Next week, we have an actual Capture the Flag event, 24-hour Mendix app hacking. So instead of problem fixing, you're going to break Mendix apps. So this is all about learning best practices for modeling Mendix apps in terms of security and information on that front. So yeah, join us then if you can. For now, thank you for joining us today. I'm Jan Vries, your low-code host, and I'll see you in the next live session.